Thank you very much for attending. What I will talk you through today is how we from Connect Flows are able to get data from Connect, extract data, do something with the data, trigger notifications. This is just one use case example. I will elaborate a little bit more on what we can do in addition by the end of this session. Similar to the session before, pretty much the same agenda. I will explain about Connect Flows, just that everyone understands what we are talking about. A little bit about the use case, what we're trying to do, the architecture, which again is very important to understand the benefits and how it is being done. Talking about the flow design, and then again Q&A by the end. So for the new people who have probably not heard about Connect Flows at all, Connect Flows is the new name for Crosser. You might have heard about that acquisition end of last year. So Connect Flows is essentially an integration platform that allows you to build integrations between systems in different levels, specifically in industrial environments. So what you see on the right-hand side is an illustration of a typical industrial environment. You have different systems on different levels, and the unique positioning of Connect Flows is that you can use the tool to build integrations across all of these different levels. You can build integrations starting with sensor data, PLC data, right on the factory floor. We can connect to MES systems, PI systems, historian systems, which are usually on level 3. But also we are able to build integrations towards global systems, ERP systems, SAP, cloud applications, Connect as well, obviously, whatever you can think of. So the idea is to provide you with a toolbox that allows you to build these integrations between different systems, which usually do not communicate with each other. For us, it's not just about sending data from A to B, it's about doing it in a smart way. In a smart way, meaning you do some data transformation in the middle, you do maybe some analytics, some aggregation, up to the point that you can embed trained AI models into such a pipeline. So all in all, what we are providing is a toolbox, as I said, in a low-code fashion. So you have the starting point with the module library. Module library gives you tons of connectors to external systems. Could be industrial systems, could be cloud-based systems, could be databases. We can read from files, native protocols, all that stuff. In addition to that, you have modules to do something with the data. Could be as simple as restructuring, aggregating, filtering, detecting outliers, up to the point where you can embed your own logic using Python, C#, JavaScript, and so on and so forth. So the idea is that you use these modules, plunge them together in a flow, configure these modules, and that represents your integration flow. Once you have that, you can go one step ahead and test these flows either in a sandbox environment or in an environment that you have spun up in a lab or something like that. Once everything's done and verified and you're happy with what your flow does, you can deploy it into kind of your on-premise systems. Important to understand is the two main components that we have. And here we have a clean separation between management orchestration and the actual execution. What lives in Connect is the so-called flow manager. The flow manager is the tool where you have the low-code design tool, where you have version control, where you configure, where users logs in. This is where you really work with the tool. Important to understand that this is not the part where the data is being processed. The data is being processed in the second component, which is called a flow runtime. This runtime can either be a Windows service, it could be a Docker container. We are agnostic from that perspective. The only thing to think about is where it makes sense to process the data. So this combination allows us to have one centralized control plane that gives you the ability to deploy, control, and version control all of integrations across your different plants, across different vehicles, across their entire infrastructure and business units. What we do report back is not the payload data to Connect, but it is usually just health status information. So when you deploy these integrations, you want to make sure that you still have insights in what is going on. Are my connectors up? How is my performance? How much memory do I consume? Message throughput, all these stuff. So some health metrics are being reported back in order to give you transparency in what is going on in your distributed environments. So with that said, let's talk a little bit about the use case and what we want to do here. The assumption here is that we have existing data again from a wind turbine in this case, in Connect. That is what we've done in the session before. We've kind of ingested data in Connect, and we will now use this data, analyze it, and trigger some actions on it. In this specific case, what we want to do is we want to continuously monitor certain data streams in Connect, analyze them, and if we detect an anomaly or something that doesn't look good, we want to send out a notification to an engineer to look up for something. So technically what we will be doing is we are kind of getting information from Connect, from different streams, analyzing it, and if we detect something, we send out a notification, in this case to a Slack channel. Could be Microsoft Teams, could be an SAP system where you create a work order or anything else. It doesn't really matter. This is more about the concept to give an understanding what you can do in addition besides just pumping data from A to B. So the architecture for this setup looks slightly different and a bit more easier compared to what we've seen before. What we are trying to do here is really getting data from a cloud-based system, analyze it, and call another cloud-based system. So I mentioned before, you should think about where it makes sense to process the data. And for such a setup, it doesn't really make much sense to have a flow runtime on-prem behind your firewall. You could just run a runtime in a Kubernetes cluster on the cloud, as an Azure Container Service, in Amazon, whatever you have available. So this is why this looks a bit more easy to understand. We have the flow manager again that lives in Connect. We have the stream store that lives in Connect. And the assumption here is that we also have the flow runtime running somewhere on a cloud level. So this is the architecture. And what we're going to do now, again, is to really walk you through this kind of concept, how to build this integration from the beginning up to the end, and then we can elaborate a little bit about what we can do in addition. So let's see, recording again, and let's hit the play button. There we go. So again, this is the flow manager. This is kind of the landing page where you have different flows. You can manage categories to assign permissions and roles and all that stuff, but that's not the core of this presentation. It's more about the functionality. So we directly go into the Flow Studio. We get a list of connectors from the library that we see right here. You see plenty of AVEVA systems. There's many more available, obviously. And what we're going to do is we want to get data from data streams. Now, one interesting part that we will see here is a new way of configuring these modules. In the past, you only had kind of a list of settings that you need to apply. Recently, we've introduced a more interactive way to configure these modules. So what we can do is now, step by step, being guided through this setup. The first thing that we need in order to connect is credentials. Credentials can be created. It's just OAuth credentials. You create them in Connect. You bring them into this solution. And here I just use predefined credentials from a library. So I select my credentials, and then I get a list of my stream stores that I have access to. So I can just select them from a drop-down, and then I go one step further and connect and select the actual data streams that I'm interested in. So really step-by-step being guided through, so you don't need to know anything in advance. It's more like a dynamic way, interactive way of configuring these things. So pretty forward setup. Once you have done everything, you end up with having the configuration in the settings overview, again, similar to what we've seen in other modules. Now, what we need to do here is we need to trigger the reading operation. So we do this with an interval module. We set it to a certain interval that might relate a little bit to your use case. In this case, I'm just pulling the new data set. I would believe it was every second. And then we trigger the reading operation from Connect and get the information. What you've seen previously was the documentation that we have in every module. That is being used to illustrate you and explain you how the modules should be used, how they need to be configured and all that stuff. You will find that concept on every module that we have in our library. So what I do know already now is that I've selected multiple points. I've selected one point from Connect, but what we want to do is we want to make this flow being able to deal with multiple data points, data streams from Connect as well. So what I need to do is I want to build a process that iterates over these data points. So now I have an interval, I get the data, and then I split the data. It might be that I get a list of 1,000 data points, and then I want to iterate and apply the same logic to add each and every data point. Next thing that I want to do is I want to create a time window of the data. Usually just looking at one single data point doesn't really tell you anything. Usually what you need to do is to create a time window for a certain amount of messages for a certain time. And that gives you a better overview about the data points. And then you can apply logic like getting out the standard deviation, detecting anomalies, and then all these things. So we do this here with the window module. So what will happen is we will send every single message into that window module. And that window module will gather the first, I believe it was 10 messages. And then with every new message, the window shifts by one message. And that is how you can build a continuous kind of monitoring of these data streams, of the values of these data streams. Next up, I add an array statistics module. And this is just as an example. Array statistics module just a defined mathematical operation to, for example, detect standard deviations and maximum minimum values and all these things. This is just treat this as a placeholder. You can even bring in a trained AI model in here and detect anomalies which are more tailored towards your kind of use case. So treat the array statistics as just a placeholder, and we're doing a simple thing here. What we want to do at the output is we want to generate a message to Slack. So what we need is a text template, and in this text template we create the message that we will send to this external system, in this case Slack. So we are setting up just an example here. We reference some data. And one important thing is we only want to do this if a certain standard deviation is reached. So we use the result from the array statistics module as a filter on the next following path in order to make sure that we only trigger the notification if something bad has happened. So we have the filter module, we have the message template module. We have the filter on top of it, which makes sure that only if the standard deviation is above a certain value, the next part will be triggered. That is how you can make sure that you send out notifications based on events. Then we have the Slack module, fairly easy to configure. Same thing can be done with a Microsoft Teams module or with any other notification system or whatever you think about where you want to send the result to. And that's kind of the end-to-end flow that we have here. What I'm doing now is enable debug on all of these modules, just to illustrate you the output step by step, similar to what we have seen before. The flow is now running in the background. I will switch back to the select mode just to see the single message. And this is kind of what you see in here. That's the result of the window module. Afterwards, we have the array statistics. Again, treated as a placeholder. Could be a Python module, could be more advanced logic, could be an AI model. Once the condition for the standard deviation is met, we generate this text message and send a notification to Slack. So the important thing that I try to bring across here is that this is just one example, right? We can read any sort of information from the stream store. You can put any sort of logic in between that relates to your use case, to your business logic, to detect anomalies or whatever. And then you can send these things out as a notification, store them in a local database, or whatever you want to do with it. So on the output side, we now have a notification. You could just store it somewhere in a database, in your SAP system, create a work order. All these things are possible. This is really more about the concept to illustrate you a little bit what you can do in addition besides just pumping data from A to B in a fairly smart way. That's all I had prepared. Thank you very much for your time. Thank you very much for attending. If something else comes to your mind later on, we will be at the booth for just a few more minutes, but otherwise, you can reach out anytime via email or whatever. All right, thank you.